Hello students, welcome to Physics with Asif. This is the revision class for CBSE Class 10 Physics, and today we begin our first chapter, Light, Reflection and Refraction. Before starting, let's take a quick review of what we'll be learning in this chapter. In this chapter, that is light, reflection and refraction, we studied two major phenomena of light, that is reflection of light and refraction of light. Under reflection of light, we learn about the spherical mirrors and the important terms related to them. Image formation by spherical mirrors using ray diagrams. That means how the position of the object affects the nature and position of the image. That is, the image formed, whether it is a real one or the virtual one, erected or inverted, magnified or diminished. And then the sign convention for spherical mirrors, the mirror formula and magnification for spherical mirrors. All of these concepts will be studied for both concave and convex mirrors. Now in the second part of the chapter, that is the refraction of light, we will understand what refraction actually is and the basic terms related to it, and then how a light ray bends when it passes through a glass slab, the meaning of refractive index, and the refraction through spherical lenses. So just like mirrors, we will study the image formation by spherical lenses using ray diagrams. That means how the properties of the image change with respect to the position of the object. And then the sign convention, the lens formula and magnification, and finally we will understand the concept of the power of a lens. So overall in this chapter, we explore two key phenomena, that is reflection and refraction, using spherical mirrors and spherical lenses respectively. In the introduction, we recall what we have already learned in the lower classes. The first point is light gives us the sensation of vision. So just like the ears give the sensation of hearing and the tongue gives the sensation of taste, the eyes gives the sensation of vision. But the question is, how does it do this? And here is a simple way to understand. So imagine you enter a dark room. So you cannot see any objects. So when you switch on the bulb, if the light from the bulb falls on the objects reflect this light, which then enters your eye. Inside the eye, the image is formed and converted into electrical signals, which travel to the brain through nerves. The brain recognizes the object, and this is how we see. And next point, what else we have learned earlier. So in the lower classes, we have already studied the basic phenomena of light, like reflection of light and refraction of light, through the naturally occurring phenomena like image formation by mirrors, twinkling of stars, the colors of a rainbow, and bending of light by mediums. So if you look at the first one, image formation by mirrors, it comes under reflection of light, and the twinkling of stars, colors of a rainbow, and the bending of light, these three naturally occurring phenomena, they come under the refraction of light. In the lower classes, we have seen the naturally occurring phenomena that depend on the reflection and refraction. In this chapter, we will explore and try to understand the same phenomena by using the objects like the spherical mirrors and the spherical lenses. This chapter starts with the reflection of light. So we start with the recalling of reflection of light. The first question is, what is reflection of light? The bouncing back of light from any surface is called the reflection of light. For example, if you throw a ball at a wall, the ball bounces back immediately. In the same way, when light strikes a surface, it also bounces back. This phenomena is known as the reflection of light. And there are two laws for reflection of light. The first law is angle of incidence is equal to angle of reflection. So here, to understand this, you consider a mirror surface and draw a line which is exactly perpendicular to the surface of the mirror, and say it is ON. So ON is the normal to the surface of the mirror. Now consider a ray which is moving toward the surface of the mirror and strikes the surface at the same point, that is O. And this ray is starting from the point, say it is A. Therefore, AO is the incident ray. And this incident ray is making an angle, say I, with the normal. So therefore, I is the angle of incidence. Since the mirror surface is a reflecting surface, then the incident ray will be reflected back into the same medium. Therefore, say OB is the reflected ray, and this reflected ray is making an angle, say R, with the normal ON. Therefore, according to the first law of reflection, this angle of incidence that is equal to angle of reflection. Just remember that angle of incidence is the angle made by the incident ray with the normal, and angle of reflection is the angle made by the reflected ray with the normal, and these two angles are same according to the first law of reflection. Now coming to the second law, the incident ray, reflected ray and the normal, they lie in the same plane, that is the plane of incidence. So here the plane of incidence is not the plane of the mirror. So plane of incidence is a plane which is drawn perpendicular to the plane of the mirror. Therefore, the incident ray, that is OA, and the normal, that is ON, and the reflected ray, that is OB, these three lie in the same plane, that is the plane of incidence. And these laws, that is laws of reflection, they are applicable to all the types of reflecting surfaces, like plane surface, curved surface and spherical surfaces. So in this chapter, we mainly focus on the spherical surfaces, that is the spherical mirrors. And if the image is formed by a plane mirror, then we will see what are the properties of the image. Suppose you are standing in front of a plane mirror, observing your image. The image formed has the following properties. The image is virtual and erect. Virtual means the image cannot be obtained on a screen. It only appears to be formed behind the mirror. Erect means that the image has the same orientation as the object. For example, when you stand in front of a mirror, your head remains at the top and your feet at the bottom, just like in real life. So the image also has the same order. The size of the image is equal to the size of the object. The plane mirror forms an image that is exactly the same size as the object in front of it. The image distance is equal to the object distance. This means if you are standing 1 meter in front of the mirror, your image will appear to be 1 meter behind the mirror. The image is laterally inverted. This means your right hand appears as the left hand in the image and left appears as the right. So these are the important properties of the image formed by a plane mirror. We start with the topic spherical mirrors. We know that mirrors are mainly of two types. One is the plane mirror and the other is the curved mirror. A spherical mirror is a type of curved mirror that is used mostly. The name spherical mirror comes because it is a part of a hollow sphere. To understand this, look at the image of a sphere on the screen. The sphere is cut into two parts and they are equal in size. But instead, if they are divided into two unequal parts, something like a bigger part and the smaller part, the smaller piece of the hollow sphere can be used as a spherical mirror. If one side of the piece is coated with silver, then the other side will be acting as a mirror. So here there are two possibilities. So if the inner side is coated silver, then the outer surface will be acting as a reflecting surface. And if the outer surface is coated silver, then the inner surface will be acting as a reflecting surface. But the properties of the image formed will be different in both the cases. Therefore, the two types of mirrors are possible. One is the concave mirror, the other one is the convex mirror. The first one, the concave mirror. In the case of a concave mirror, the reflecting surface is a curved inward, and the reflecting surface, it faces toward the center of the sphere. To understand this, you draw a sphere in two-dimensional view. So it will be simply a circle. And the center of the circle, say it is C. This point C, it represents the center of the sphere from which we are going to take concave mirror and the convex mirror. Now you cut a piece on the right hand side, and outer side of this piece is coated with silver. So it is shown with the gray colored part. So since the outside of this piece is coated silver, the inner face will be acting as a reflecting surface. And this reflecting surface is facing towards the center of the sphere. The second one, that is the convex mirror. So in the case of a convex mirror, the reflecting surface is curved outward. To understand this, you take one more piece that is shown on the left side of the circle, and the inner face of the piece is coated silver. Therefore, the outer face will be acting as a reflecting surface, and this reflecting surface is facing away from the center of the sphere. So these are the two types of spherical mirrors possible from a hollow sphere. And next we see all the terms related to spherical mirrors. Okay, the first term is the pole of the spherical mirror. It is the geometric center of the reflecting surface and it is denoted by P. So it is shown here with the point on the reflecting surface. In the case of a concave mirror, the reflecting surface is curved inward. The center point is the pole of the mirror, and in the case of a convex mirror, the reflecting surface is curved outward and the center of that surface is the pole. And we can see the pictures here, a concave mirror and a convex mirror. The center of the concave mirror on the concave inward surface, okay, that is the pole. So this point P represents the pole of the reflecting surface of the concave mirror. And in the case of a convex mirror, the reflecting surface is curved outward and the center of this surface, okay, that is shown by the letter P, is the pole of the mirror. The next term, the center of curvature. So it is actually the center of the sphere itself. It is denoted by C. Okay, and how do we define it? The center of the sphere for which the reflecting surface of a spherical mirror forms a part. So here we are showing both the types of mirrors, that is convex mirror and a concave mirror. These two mirrors are forming the parts of the sphere. Okay, therefore these mirrors are called the spherical mirrors. Therefore the center of this sphere is called the center of curvature of these two spherical mirrors. And one more point is the pole of the two mirrors, they are lying on the surfaces of the spherical mirrors, but this point is not lying on the surfaces of the mirror, it is lying outside the spherical mirror. And in the case of a concave mirror, it lies in front of the reflecting surface, but in the case of the convex mirror, this point, the center of curvature, it lies behind the reflecting surface. The third term, that is the radius of curvature, and simply it is the radius of the sphere from which you are taking a concave mirror or a convex mirror, that is a spherical mirror. From this figure, okay, the distance between the center of curvature and the pole of this spherical mirror, it is defined as the radius of curvature. Since we are showing both the types of mirrors from the same sphere, so either you can take on the right hand side or you can take on the left hand side, that is this distance will also be the radius of curvature of the spherical mirror, and it is denoted by R, and this R is equal to PC, that is the distance between the 2 points, that is the center of curvature and the pole of the mirror. And the next term, that is the fourth term, that is the principal axis. So principal axis is the line that is passing through the pole of the mirror and the center of curvature. So here pole of mirror is P and center of curvature is C. Okay, here we are showing two types of mirrors, so you don't need to confuse here. Always you think about either the concave mirror or the convex mirror. So if you are taking the concave mirror, then the line should be passing through the pole of the concave mirror and the center of curvature of the mirror. Therefore the line will be passing through the C and P, okay, these 2 points C and P. Otherwise, if the second convex mirror is considered, so in that case also the line should be passing through the center of the curvature and the pole of the mirror. And at the point P, okay, for a concave mirror or a convex mirror, this line, the principal axis, it will be exactly perpendicular to the reflecting surface. Therefore the principal axis is the normal at the pole of the given spherical mirror. The next term is the principal focus, that is the fifth term. So to understand the principal focus, you consider a beam of parallel rays. So these beam of parallel rays, they are parallel to the principal axis and they are incident on the reflecting surface of the concave mirror. And after reflection, these rays, they will be passing through a single point on the principal axis, and this point is called the principal focus of the concave mirror. And therefore it can be defined as the principal focus of a concave mirror is the point on the principal axis where all the rays that are parallel to the principal axis converge after reflection. Now in the case of a convex mirror, you just consider the same set of parallel rays that are parallel to the principal axis, and after reflection, okay, they go in different direction, okay, they appear to be coming from a point from the principal axis. That is, if you just extend all these rays in the backward direction, okay, they appear to be coming from the same point. Okay, this point is the principal focus of the given convex mirror. and it is represented by the capital F. So therefore, how do we define? The principal focus of a convex mirror is the point on the principal axis from which all the rays parallel to the principal axis appear to diverge after reflection. The next term, that is the focal length. The focal length is the distance between the pole and the principal focus of the spherical mirror. In the case of a concave mirror, so it is the distance between these two points, that is F and P. Okay, this is the focal length of the concave mirror. And in the case of a convex mirror, the focal length, if this is the principal focus, then the focal length will be the distance between P and F. And the last term, that is the aperture. This is the seventh term. Okay, to understand the term aperture, okay, you just take the spherical mirror, and if you just look at the spherical mirror, the outline of the spherical mirror is a circular, and the diameter of that circular outline is the aperture. Therefore, you just draw a line, the perpendicular line, okay, from one end to the other end. Okay, this line, that is Mn, that gives the aperture of the given spherical mirror. It is simply the diameter of the circular outline of the spherical mirror. For the spherical mirrors of small aperture, the radius of curvature is twice the focal length of the spherical mirror. From the figure we can understand this, that is, if r is the radius of curvature and f is the focal length, then r is equal to 2f. Therefore, it shows that the principal focus, that is capital F, it lies exactly at the middle of the center of curvature and the pole of the spherical mirror. So these are all the 7 different terms that are related to spherical mirrors, and we'll be using these 7 different terms that are related to spherical mirrors most frequently in the image formation by spherical mirrors or the representation of the images by using the ray diagrams in the case of spherical mirrors. Thank you for watching the video. If you found this video helpful, please like, subscribe and share with your friends.